Hi, my name is Pardasan Sao. I am solving a LeetCode problem 169, a majority element. I am referring from the DSA sheet from Apna College, that is from Alpha Batch. So let's begin and let's start with the Darshan code. So let's start with the question. We have the majority element LeetCode 169, and the definition is given an array of nums of size n and return the majority element. Let's see what is the majority element first. The majority element is the element that appear more than n by 2, right? And we have also given that you may assume that majority element always exists in the array. So let's consider this input, nums equal to 3 to 3 and output is 3. How is 3? Because the frequency of 3 is more than n by 2. And so first approach will be the brute force approach. In brute force approach, we are simply iterating every element and find the frequency of each element and check the frequency is more than or equal to n by 2 or not. If it's equal or more than, then return that number, else we have simply go to the next element, right? Then after the time complexity of the this approach is order of n square, and it is not feasible, right? And the space is 1 because we are not taking any extra space, but the time complexity may hamper. So in the second approach, we are using HashMap, or simply we can say the counting the frequency. We have to use the HashMap or a dictionary to store the count of each element as we iterate, right? So we have to simply iterate one time of array, and then after find the frequency. If the frequency is greater than n by 2, or maximum frequency of the any element is the majority element, right? Then after we can say that the time complexity of this approach is order of n, because we are simply iterating an array one time only, but the space complexity may increase. So this is not a feasible solution also, because it will take a space also, but it will decrease the time complexity, right? So our third approach is the sorting algorithm. The sorting algorithm help us to find the majority element such that the majority element always occur in the n by 2th term only. Like if the element occur more than n by 2, it is guaranteed to occupy the middle position of the sorted array. But the major problem is the time complexity. Due to sorting, the best sorting algorithm we can use, and the best sorting algorithm time complexity is n log n time, which is not suitable for this algorithm, because we already uses in the previous approach order of n times. So this is not suitable, but it will decrease the space complexity to the order of 1. So our fourth approach is the Boas-More voting. It is the most optimal approach solution. Think of it as a king of the hill game. We have to maintain the candidate and the count. If count equal to 0, then we have to pick a new candidate. If current number is equal to a candidate, then increment 1. If a current number is not equal to a candidate, then decrement. And since the majority element is n by 2, it will survive all the cancellation. Like here we can see that this is the count and this is the array we have given. Like we can simply take and assume that this is an array we have given. So we have to take one candidate and we have to increase 1 with count. If the candidate is equal to the given number or given shape, we can simply increment 1. if this is not equal, like the candidate and the number or a shape that is given here is not equal, then we will decrease that, right? Like here you can see that this 2 is equal, then we will increase. Then this 2 is not equal, then we will decrease. This 2 is not equal, and here you can see that the candidate is equal to the like current count will be equal to the 0, then we have to take another candidate. So if the candidate we have to take another candidate, and candidate equal to 1, and here you can see that if this is not equal, like here you can see not equal, then it will simply decrease by, the count is decreased by 1. Then after here you can see that count equal to 0, then we will choose to the next candidate and increase the count to the 1. Then after here you can see that these two are equal, then we will increase. These two are not equal, then we will decrease. These two are equal, then we will increase. These two are equal, then we will increase. These two are not equal, then we will decrease. These two are equal, we increase. These two are equal, we will increase, right? If the array element is end and we have simply count equal to more than 0, then simply the candidate will be the majority element always. It will take simply it will take a time complexity of order of order of n, because we have to iterate one time, and we don't have to take any other space, right? Only we have to take two variable space, that's all. So the time complexity you cannot see right clearly, but this is a brute force, and brute force time complexity will be order of n, and the space complexity will be order of 1, which will not feasible. And if we use the HashMap, the order of time complexity will be the order of n, and the space complexity will be order of n also, which is also not feasible because of the memory uses. Then after we can use sorting algorithm, but it is not feasible because we have to solve in order of n time, right? And here sorting algorithm take around order of log n time, order of n log n time, and space complexity will be 1, and Boas-Moore will be order of n, and space complexity will be order of 1. And let's go to the LeetCode. So in LeetCode we are simply solving the Boas-Moore code, and so here we are taking a two variable current majority, which is equal to 0, and the current count will be equal to 1, or simply CNT equal to 1, right? The current majority is the candidate that I mentioned before, and the count will be the count only. So we will iterate from the 0, we will iterate through the array, and if the count is equal to 0, like here you can see, and the current majority will be equal to nums of I. Here we are assigning a new candidate if a count equal to 0, and we will simply increase the count equal to 1, right? Here, like here you can see that if the we are assigning a candidate, we are simply increase a count to the 1, right? Then after, if a current measure equal to num, then we will increase the count. Like here you can see, if the two candidate and given the number is equal, then we simply increase the count to +1, right? Then after, here if the else will be decreased by 1, right? Like here you can see, if the candidate and the given shape will be different, or a number will be different, then it will decrease. Then if we simply run this program, the code will be run that's all about our majority element. And if you like this video, please like, share and subscribe, and goodbye.